Hello. Today I'd like to present my project for the BigQuery AI Hackathon in Kaggle. And my project is Gig Workers Stress Levels, a data generator tool to analyze drivers' stress levels and allow proper ML-driven management. So why am I working with this topic? I've been also studying a little bit about this topic, and I found out that from gig workers, I mean like iFood, Uber type of work, there are many testimonials online that report that something is going wrong or not great with the way that they are being managed. And it seems obvious that the tool, the app, is managing people through a machine learning um, application. And I will share here a little bit of the testimonials that I have found online. For example, this algorithm makes punitive decisions against workers due to a negative customer review or a high trip cancellation rate. Second, when you realize how your job can be threatened by a simple comment on an app. The third one, it's difficult to contact the company for an explanation. There's no formal appeals process, and little assistance is given to delivery drivers. And also, decision makers are invisible and unknown, which reinforces drivers' feelings of isolation. And the last one, communication remains standardized because the real decision makers are inaccessible and unknown, which leads Uber drivers to internalize their feelings. So I think this is an important topic to work on. And nowadays, unfortunately, companies will be looking for a way to make more money, to be profitable. But I'm thinking it's also possible that we find a way to meet in the middle where we can also be worried about those workers and make their life easier. So, but also we not always have like the inputs, the information necessary to include in the app, in the machine learning driven management tool, to proper guide or to give a proper response for the driver that is better for them. So this is also an employment model that's on the rise. And in case of Brazil, it's still unregulated, at least for now. We are close to like a law, some kind of a law plan being approved, but we're still in the process of that. So introduction to my project. I used simulated data. This is city-wide data set. This is actually from Kaggle. I thought this was pretty much what I was looking for. So it's basically for my project, I started uploading driver's data and rides data where I can join both and identify like how the driver uh, which trips the driver got, what was the fare, what was the distance for the drive, and some things like that to create some aggregated metrics by driver. So basically, the data flow for my project is first upload here the data sets that I shared. And the first part to apply BigQuery AI features is to build the drivers metrics. I'm using two fields here that I'm using generative AI. For one of them, I am creating an AI generate double, which is in format of values from 0 to 1, and I'm creating a field called the stress score. And what I'm basically doing here is I'm gonna show you guys. So basically, I'm getting the tables that I shared, joining them together based on the driver ID and creating some metrics. Total rides, the total fare that the drivers had, duration in minutes of work, and after that, I calculate besides total rides, I'm calculating like um, the maximum total rides, the average total rides, in a day. And also, let me see. In here, we have by date. So I'm aggregated everything by date first. And then in this part, I'm aggregating to see uh, the average by day, without the day in this case. So maximum total rides, average, the minimum, the maximum. So looking at each driver, I'm seeing like if he worked like for a full week, um, what's the maximum amount of rides that he took like in a day. So just to be clear about what I'm doing here. And at the end, I am kind of I'm using generate double um, to generate stress levels from a score from 0 to 1. And a good practice for prompting would be like to give an example. So in here, I'm using many information about the driver, and I'm including in some kind of sentence where I'm including the information about the driver. And also, I'm giving a top example here, which this could be great for other companies that actually like have studies on this, and they can share like if this is the case, the driver uh, has some years of work, has some rides on average on a day, uh, he has this amount of stress level. So I'm in this case, I'm just using like an example from my mind, from my head, just to show you guys how we can use this tool. So and for the second part here, sorry, in this part, I'm using AI.generate function to create a stress reason. I'm sorry if this is hard to watch. Uh, this is hard to see. So in this case, I'm creating a stress reason field, and to create a two sentences report based on the driver profile. So what I'm looking here is for something like this, where I have a stress score and the stress reason. This would be an attempt to, instead of getting feedback from the drivers, I can try to simulate the stress reason why they are stressed, because I can have the score being one for different drivers, but the reason they are stressed are different. So this is the idea here, to grasp like different reasons for stress. And it doesn't mean that if I change something for that driver that is super stressed, it doesn't mean it's going to solve the same problem for the other one, because the stress reasons are different and we not always know what they are. So this is the first part. Um, Sorry, I didn't know how to open directly in this slide. So in this case, I'm going to present everything. In this case, the next step here, after I generated this, is now that I have more data about those drivers, I'd like to um, create a new view, which is the driver's reason tags, which is basically from the stress reason that I created, like the two sentences feedback. uh, Please use AI generate again and export like three main tags that represent that feedback. So basically here I'm using this format like tag 1, comma, tag 2, comma, tag 3, and it's up to 3. If the generate AI uses only 2, that's or 1, that's okay too. I'm asking up to 3. And this is it. So I'm going to show you an example like, so this is the query, by the way, and I'm limiting of also like a two words by by keyword. So it can be one word, two words. So in here we can see the data generated. So by driver ID, we have stress report tags like income variability, moderate stress. For this one is income variability, low rating, moderate stress. For this one is financial uncertainty. This is one is low workload, and which low workload can also be stressful. Um, so let's continue the presentation. For this one, after I have the tags, what I want to do here is use BigFrame's ML LLM text embedding generator, which is another function from that I can use in BigQuery. And well, I mean, together with BigQuery. And in this case, I'm applying this inside Python. And you will see that in GitHub in the repository after the main here, um, I am printing like every step that I'm showing here. So uploading the data, creating the metrics, the driver's metrics that I show you, then I'm creating the driver's reason tags, and then I'm embedding, which is what I'm showing you now. Okay, so this is the function generate driver reason embeddings. So basically I'm getting the stress report tags, and for this one I'm getting a list of unique reasons based on the list of tags, and then I'm embedding those responses using the text embedding generator. And so in here I'm like extracting the embedding together with the unique reasons, and then mapping them back to the driver ID, so I can know like this embedding by the driver ID. Okay, so after this, I think I will continue to explain here because there's two in these two steps I'm kind of handling embeddings. So for the embeddings, we create like a huge list of doubles, and for plotting the results, I am using Disney. Where is it? Here in plot. I'm using this TSNA, Disney, to reduce my embedding into two components. So in that case, I can use it to plot it by X and Y and show uh, all the drivers. And I'm also coloring them by the main tag. I could, I preferred, I mean, there are a couple of ways to work on this. I decided to like just split the list of tags and just get the first one and then use that to color the image. So I will show you guys going back to the presentation. So basically here we finish the data flow, apply scikit-learn Disney to transform to two components, and then with that we plot the final image. The final image is this. So what I wanted to accomplish with this, every dot is a driver, and in this case I was looking for like seeing if the embeddings would be able to grasp similarity between drivers. So even though we have like unstructured data, or we can have like text from like free text that many drivers can tell their story, etc. We can use AI to generate or uh, to create tags that reflect to that feedback. And then I was hoping that with the embedding, we can get the data approximated, and we can check for clusters or something. This is like not huge clusters, and I'm also aware that this is a lot of tags. I could have a better clusters if I chose like maybe 5 of them, but this is a simulated data from Kaggle, and in my mind, I think it's good enough to show my case. So I I put a circle here in some cases that I find interesting that it puts dots on the same color close together, and that's it. So I'd like to go over like what is finally what for the impact of this case. I'm interested in sharing like that every driver has a different story, and for that case the companies Uber, iFood, Uber Eats, and other types that work as gig worker model as well, they can all be impacted by this, and they can adjust their management, their way of doing the management through the app to reduce stress levels on the workers, because they're already complaining. The workers are already complaining that they're stressful with the way the things are. And maybe it's not because the company, of course, sometimes it's only worried about profit, but it's not only that. I mean, I think it's possible that they're just maybe didn't have an idea to how to include those insights, or maybe didn't even think about it. So my approach here is to, uh, hey, let's like, I want to call everyone to look for this issue, and maybe it's a way that we can improve the way that we do this, and we can uh, make them work better. So, for example, like we have driver works longer hours but consistently receives below average payments. This is an issue. At the same time, the gas prices rise and the local strike starts, increasing financial and emotional stress. Um, so in this case, um, the if many drivers in the region are working long hours with low earnings, and external factors like fuel price hikes or strikes are detected, the platform can temporarily adjust pricing or incentives and redistribute demand to mitigate stress and stabilize income opportunities. So this is one case. The other one is like the worker stays available all day but receives very few trip offers and has a low rating, which can be very stressful as well. So the action plan for the second example would be to look in those regions if there are long idle times. The platform can rebalance trip distribution or adjust the incentives to equilibrate demand across nearby drivers, reducing prolonged inactivity and frustration. So maybe this is something that is not taken care of today, and now we can have maybe the data to understand like even if we change something, what would be the impact? We can look again at the data and see what's the impact for those drivers. Also, this is important because um, we won't be asking like feedback for those for drivers and delivery couriers like every single week. So it's good that we have a generative um, AI tool like that, so we can like have ideas on how to extract based on the data, on numerical data that we have instead. So um, this is my presentation. I hope you enjoy it. I hope you find it useful. I would have like a lot more things to say about this, but I think this is enough for now. And I'm happy to be a part of this competition. Thank you very much.